weak, base, strong. 3 levels of model control, simple and beautiful. We now have access to the Haiku, Sonnet, and Opus models in our sub-agents. In the background here, I have 12 sub-agents operating across these 3 levels of intelligence, speed, and cost, conducting crypto research for me. They're setting up my next big trade. Now, obviously not financial advice, but you can see here running 12 agents in parallel with different levels of compute, Haiku, Sonnet, and Opus. You and I are able to do more deep research and more wide research than we ever could before. The Claude Code team continues their blazing red hot streak as they ship another set of surgical, minimal useful features. We have sub-agent model selection, agent mentions, and hidden file mentions. We do have bad news though. We have new rate limits. Someone watching the IndyDevDan channel took the infinite agentic loop, parallelized it, and ran it 24/7 and ruined it for the rest of us. In this post, Anthropic mentioned something really interesting that caught my attention. We're committed to supporting long-running use cases through other options in the future. With the success of Claude Code and the Claude 4 series, you and I can bet that Anthropic is betting on highly agentic, long-running systems and models. So I'm thinking ahead toward what Anthropic could be releasing next. But I have to say, with all the excitement around Claude Code, it's pretty clear engineers like you and I, and now a decent portion of the Gen AI tech industry, we're all overexposed to Claude Code. We have too many eggs in one basket. This is bad investing. I don't think these rate limits are unfair at all, but it's woken me up, and maybe it's woken you up too. We need Claude Code alternatives. We have too many eggs in one basket, right? We're addicted. We need help. We're Claudeaholics now. We need alternatives. Not because Claude Code isn't great. It's because it's too great. With these new rate limits coming in, as they mentioned, it'll affect less than 5% of users, but you and I, we're probably in the 10 or 5%, and these rate limits are coming, right? August 28th. It's kind of perfect timing that this came out with their brand new model selection feature. In this video, we're going to take a look at that because you can see across 3 versions, and speaking of limits, right, there's my Opus limit coming up right here, but you can see across 3 versions, I have Haiku, Sonnet, and Opus running the exact same prompt. We're going to dig into this so that we can understand that we don't always need the highest levels of compute to solve problems. The ability to select the right model for the job is ultra important. And I think this powerful, weak, base, strong model stack for our agents is going to be a great way to navigate not just rate limits, but it's going to help us navigate costs, speed, and intelligence trade-offs. I've been thinking about this for a while as I continue to, discuss, use, and really lean on Claude Code. We're over-levered. Right? Just like an investor has too much stock, too much of their portfolio in one tool, we have a lot of engineering resources, time, dependency on Claude Code at this point. So with the release of Qwen 3 Coder, 480 billion parameters, everything that keeps shipping inside of the Gemini CLI, right? I'm keeping my eyes on all of these agentic coding tools, all these agentic model developments, and with the recent news that Anthropic had to revoke OpenAI's access to Claude, 2 things are very clear to me now. Claude Code has completely changed engineering, and alternatives are on the way. If you're an industry leader, you will always be copied and cloned. Claude Code is the industry leader for agentic coding. It is being copied and cloned all over the place. In upcoming videos, we're going to be looking and investigating some of these open source alternatives, some other closed source alternatives. It is time to diversify, all right? But, let's be super real. No one is close to Claude Code. Let's keep cooking with the best agentic coding tool in the game. Let's break down a few powerful agent orchestration patterns with sub-agent model selection so we can use the right agentic coding model for the job at hand while avoiding these new rate limits. My crypto research can run with this single / command, and it kicked off 12 agents. Right away, we have to point out something really important. Look at the time differences, look at the token differences. These small, fast, cheap models are going to do less work for you, but they're going to do it in a short amount of time. While Sonnet and Opus are going to scale up the amount of tokens, the cost, and the time consumed. You can see it's writing this comprehensive summary for us with 12 output tool calls in parallel. Let's let our primary agent cook some more, and let's answer the question, what does model selection really offer you? Ultimately, it lets you solve two problems: model overkill, where you're wasting tokens and money, and model underperformance, where you waste time having to improve your prompt or fire off the larger, more powerful model after wasting time on the cheaper model. Okay, it's all about the trade-off, right? We're always trading off three things when we're selecting our models: performance, speed, and cost. You can optimize for performance, you can optimize for speed, and you can optimize for cost. I always advocate that you want performance over everything else, right? This is why we spend to win. This is why we have that big Claude Code Max $200 subscription, right? However much you can push it, you want to be pushing it for the compute. The compute is absolutely worth it. There's nothing more important in the generative AI age as an engineer than your ability to scale up compute and use it to solve real engineering problems. This is the name of the game. This is what every winning engineer is doing right now. I guarantee you that, bar none. When we double click into this, it's quite a simple equation, right? We have Haiku 3.5, our weak model. We have Sonnet 4, our balanced workhorse model. And then of course, Opus 4. When you're solving real problems, when you're building out things and you want performance over everything, you choose the best model. And you can even push this further, right? Model selection is just layer one. The next layer is of course thinking, right? You can specify the information dense keyword, the IDK, think hard, ultra think, right? Anthropic has encoded this keyword for us so that in our prompts, we can activate this feature whenever we need to, right? And I highly, highly recommend, if you're not doing this, you need to be using this. If you look at the charts, if you go on artificial analysis, if you run, examples yourself, Sonnet 4 thinking beats Opus 4 base. Also, of course, Opus 4 thinking beats Sonnet 4 thinking. So that's a really important call out. There are other dimensions of your model that you can push. This is the trade-off we're making when we're selecting models, when we're using models. And, there's a fourth kind of hidden dimension here. We also have to work against APIs and rate limits here. This is kind of the hidden dimension. This is probably something we're going to want to add in the future as we scale up our compute and start running those big, long running. We're talking hours and hours and hours long engineering workflow. All right. Why are we hitting these rate limits more? What's going on, right? How are we able to scale up further? It's of course because of sub-agents, right? We can now spin up multiple agents from our primary agent. We covered this in our last video, and now we have more compute than ever, and we can specify what our sub-agents do. We can now write system prompts for our sub-agents, okay? So we just had this crypto analysis run. I have a couple interesting ideas here that I want to share with you, all stemming from this crypto research custom / command, all right? And so, funnily enough, I am at my rate limits for the day. This is kind of perfect timing. I'm glad I'm filming it right here. Rate limits are obnoxious. I'm on that $200 plan, but you can still see here, I am hitting rate limit. There is absolutely an argument for selecting the right model for the job, right? You don't always need top-end compute. And especially when we're deploying our agents into production environments, you want to use the right model for the job. You don't want to go overkill, right? Remember, model selection solves two problems: model overkill and model underperformance. You want to hit that sweet spot if and when it matters. A lot of the time, you probably do this too, right? A lot of the times we just go model and we just go right to Opus, right? I just want the best model, and then you always throw on thinking mode and you let it operate at the highest possible intelligence level just to get the job done, right? This is great. I do this all the time too, but as you're scaling up parallel sub-agents, parallel agents, running multi-agent workflows, right, on device and off device, these rate limits, I think, are going to come into play more and more. I feel like rate limits have never truly been more important than with compute, right? Because let's say you hit the daily or the weekly limit, that's it, right? And this is also why it's so important for us to find alternatives. Anyway, more on that in the future. Make sure you're subscribed and like. We're going to be investigating and benchmarking agentic coding tool alternatives. Back to this prompt, right? Let's talk about model selection. So let's go ahead and open up Cursor. Let's understand this crypto research prompt. A couple new features coming out of the Claude Code team. Let's just go ahead and pull up the official docs /release. And we have three important features to cover here. So we have agents with custom model support, at mentions for custom agents, and we have at mentions for hidden files. This is super important. Now we can do something like this. And now we can see all of our .claude files. And do we have anything else here? Let's see, .mcp, right? So now we can see our .mcp file here. What's going on here? So I have a custom / command that is kicking off 12 agents, and really it's kicking off 4 distinct solutions with 3 levels of agent each, right? Haiku, Sonnet, Opus. This is a great way to understand what model do I really need to solve this problem. Okay, so you can see there we're kicking off a bunch of crypto agents, doing crypto research, macro analysis, investment play ideas, so on and so forth, right? So we can go ahead and just collapse. Here's the prompt format we have here. Top level kind of purpose, variables. We're just passing in a ticker. We have our agent groups. So we're defining, what teams of agents are going to run. And then we have execution instructions. So this is, I also like to call this workflow. And then we have our output format. So output format is super important when you're writing these prompts. This forces your primary agent to communicate to you what you want your output format to be. And for your agents, it forces your agents to report their output. So right away, you can see something interesting here in this system prompt for my crypto market agent. There's not much here. In fact, all I'm doing here is referencing another prompt. And so this is a pattern that I want to share with you here. You can have sets of agents at different levels, right? Different model levels, different descriptions, right? So that you can ABC test against one prompt. Right. So I think this is a really powerful pattern. It's also useful so that you can test this on your primary agent, right? Instead of it just being one system prompt inside a specific agent, you can test multiple prompts against multiple agents. Now you do have to keep in mind, this is still the system prompt, right? So what we have here is a system prompt, right? And you can see here we have that output format from our agent system prompt. The key thing here is that, let me copy this reference here. You can see for our 3 agents, Haiku, Opus, Sonnet, we're using this exact same prompt. So here's Haiku, here's Opus. You can see all that changed there. Let's go back and forth. All that's changing there is our model, color, and agent name, right? So this lets us, again, ABC test our model and our description. Okay, this is cool. Inside of each one of these prompts, we are of course doing specific crypto analysis, crypto research. So let's go ahead and open up macro crypto correlation. Inside of this prompt, let's go ahead and just open this up. We have, classic prompt format, purpose, instructions, workflow, output. You are a macro crypto correlation analysis expert. Here we want to understand how global macro plays into the traditional market. Of course, we have instructions, and then we have our workflow, right? Our step-by-step play for the subagent. Always remember, this is the system prompt we're operating in here when we're calling subagents. And, just to make this super clear, we covered this in our previous subagent video from last week. You are prompting your primary agent. Your primary agent is prompting your subagents. Your subagents are responding to your primary agent, not to you. The flow of information matters here, especially when you start scaling up to, and we've covered this, multi-agent workflow orchestration, where you have multiple prompts firing off back to back to back. It all feeds into your primary agent's context window, okay? It doesn't return to you. So when you read these agent prompts, right, we have a bunch of _agent_prompt.md. These are all returning to your primary agent. And so that's why we have this. And if we go up to the top level, crypto research, we have this output format call on the top level crypto research, right? This is that top level prompt that we executed to kick off our 12 agents across 3 different models. Their output format here is really important. So we're taking each response directly with no modifications, no summarizations, and no changes. Okay, super important. Again, we're referencing Anthropic's encoded keyword important. We're prefixing this with important so our agent pays more attention to it. And then we have our output format. All right. So now we should be able to just find these, right? So if we open this up, collapse everything, and we go into outputs, you can see we have 2 files here, 10, 56, 14. Here we go. There are all of our prompts. You can see it's in that exact same format as specified. And then we can take a look at each level. Okay. And so this is the really important part, right? Every level matters, right? You don't always need Opus for certain things. You don't always need Sonnet, but you can see in some cases, you can drop all the way down to a cheap, fast Haiku model. Let's see if for something like Crypto Coin Analyzer, do a side-by-side here. So that's Haiku, here's Opus, here's Sonnet. Very clearly, the Haiku model is having a problem. It's having a challenge with the format. And if we open up our Crypto Coin prompt and go down to our output format, you can always check for model strength by looking to see if it can obey your output formats. So we're looking for output in this structure, cryptocurrency analysis. And you can see here right away, Haiku goes off the rails, right? If we move over to Sonnet, we can see that it's not exact, but it gets a lot closer. We have, market data, recent news and developments. There's the market data. And if we search for news, you can see we have a news section here on Sonnet, right? So this looks better, right? We can work with this. If we go to Opus, however, and search for that exact header, we can see we're getting that exact header. And this is a really important call out, right? If you want maximum performance, you always scale it up to that top model, right? You pay to play. And this is something I see some engineers are so scared to spend. They're so scared to, use that maximum compute and really pay to play. This is a massive advantage. Understanding what the maximum capabilities are and getting the advantage of using them will set you ahead. It'll break you away from the pack. When I want to use the best, I don't hesitate, okay? You can even push that further. Of course, as you know, you can add thinking to these models. You can force them to think more, use their reasoning effort, increase intelligence even further. Of course, you're going to spend more to do this, right? They're still generating those tokens, even if you can't see them. And you want to be especially careful with this with sub-agents, right? Because this stuff is still happening. You want to be making sure that you're using the value of your top-level agents, specifically your Opus agents or whatever your strong model is. Make sure you're getting value out of this. Don't be wasteful with this stuff. Unless you're learning something or experimenting, you really want to, use these models with a clear purpose, all right? Keep that in mind too, and always remember you can push the model further with thinking mode. Just to mention it, Sonnet 4 thinking is very, very powerful, right? More broadly, this pattern of having a weak base and strong model for your agent model stack is super powerful, right? It's super important because you don't always need Opus, right? Sometimes you're just summarizing some work so you can drop down to a simple model. And this applies across model providers, right? Gemini Flash Lite, 2.5 Flash, 2.5 Pro, and then, there are bigger levels above and below. Gemini just put out their Deep Think model, while OpenAI has O3 Pro. They have their new agent model, and they have apparently GPT-5. We'll see about that. I think this is a great pattern for you to kind of select models and use the right model, right? It's all about that perf, speed, cost trade-off and, the kind of hidden layer rate limits. We're scaling up our compute across multiple dimensions now. If you want to scale, it's pretty clear that reusable prompts, aka custom/commands, and sub-agents is the way to scale up your compute and get more work done than ever. So this is a powerful agent pattern you can use. You have your top-level agent calling a custom/command. Here, we're doing crypto research. This fires off many sub-agents, right, across different model levels, and then it takes the results and refuses them, right? In a big way, we're just doing what we've done for years on the channel, prompt chaining and fusion chaining, okay? We've covered this stuff a long time ago before reasoning models even existed. Inside of your agents, you can do something really powerful. You can create dedicated agent prompts to reuse across different agents to understand what model performance you really need. That looks like this. If we go into agents, we go into crypto, you can see we have crypto coin analyzer Haiku. We have the exact same version for Sonnet, right? There's that Sonnet, and we have the exact same version for Opus as well. So it's all just a small tweak to understand what model you really need for the job you're doing. And this is why it's so important to isolate your prompt for your sub-agents. This is just a pattern. It's an idea that you can use. And another advantage here is, of course, we can just hop into a new agent and we can just fire this prompt off ourselves, right, on the top level. Okay. Whenever you want to, you can understand what your prompt is doing and how it performs by just running it on the top level, right? So here we can just run our crypto coin analyzer agent, and actually we need to pass in a, let's do BNB. This is a great way to understand what your prompt does end to end and to make tweaks to it by running it on the top level, right? In your primary agent. A lot of things get lost when you're running sub agents. So you can use this dedicated agent prompt pattern to understand, what model you really need for the job. The way I look at it is a lot of my simpler tasks where we're just generating unique names for files, where we're doing some small file moving, some file migration, some quick summarizations. Haiku 3.5 can do a lot of that stuff, right? In fact, you probably have seen, this little pop-up here from Claude Code. Guess who's running that? This is a Haiku model making up, a relevant one-word description, right? The perfect example for that, right? You don't need a big model to do that. You need something fast and cheap and simple. So that's a small example of how you can use a small, fast model and avoid using a bigger, stronger model, right? Even like Sonnet 4. Then there's, of course, the Sonnet 4. This is a workhorse model, right? This is our base level model. This is going to be a great balance. I think a lot of work happening right now is coming out of Sonnet 4. It's funny to think about, what model is responsible for the most code in the world. And I think right now it's very clearly Sonnet 4. And then of course we have Opus, right? When you're doing serious work, when you're putting the pedal to the metal, you use Opus 4 and you scale it with thinking mode, right? I do this all the time. Any complex work, any, serious engineering work, production work, Opus 4, think, burn up the tokens, hit the rate limits. It doesn't matter. The compute is there for you to use. Right? And so we can take all these models, we can take them in thinking mode, we can embed them in sub-agents and scale them up, right? And so in the end, we get something like this, right? A powerful multi-agent orchestration workflow. This is just one simple example of work happening. All feeds back into the primary agent. Primary agent can then execute on all that work, right? This is just one workflow. Again, we covered this in our previous week's video. I'll make sure to link that. You want to understand the model controls. You want to understand your tool, and you want to understand what you can do with them, right? Every week here, that's what we're pushing toward, understanding the best agentic coding tools so that we can build systems that work for us while we sleep. That's always been the focus. It's always been the mission of this channel. We're going to build living software that works for us while we sleep. We're getting closer than ever with Claude Code, with these incredible long-running jobs and sub-agents. But we also need to make sure that, when rate limits pop up, when the next set of restrictions or, whatever comes next, we need to make sure we can diversify. So, again, as you know, this is like my 15th Claude Code video in a row, unprecedented for this channel. But I follow and focus on the signal of the best tool for the job. Right now for engineering, there's no better tool than Claude Code. But we need to make sure we diversify. We can't be so reliant on a single tool, on a single set of models. Right? We have to make sure that we can do more. We have to make sure that, we have other agentic coding tools. So I'm keeping an eye out for that, right? We just had that Quinn 3 drop. We have Gemini CLI improving all the time. And then we have a bunch of open source alternatives that I'm going to give a serious sit down to really soon here. If you've reached out or emailed, I'm going to be covering a lot of the open source agentic coding tools coming up here and comparing them, doing really concrete comparisons to the industry leader, Claude Code. Don't underestimate the power of model selection, right? Our crypto research agents did a ton of research for us. We can look at Opus, big plays, right? Let's go into markdown format. Crypto play report, strong bullish momentum, XRP, interesting, right? SEC settlement rally, thesis, there's an execution, right? So we have this interesting bull case, all this interesting research, right? Solana DeFi ecosystem, okay? Huge return on investment. Again, not investment advice. We're just looking at some of the results that our agents created for us, okay? Crypto investment agent prompt. If we look at the response format, once again, we can see that Opus is obeying the prompt output format very well. We can open up the equivalent Sonnet version, and you can see Sonnet is getting close here as well. It also has this, little header here, which we didn't ask for. But overall, it looks like Sonnet is doing the job for the crypto investment plays idea, right? It has a play here, crypto accumulation at key supports. It's identified some dip spots for us to come into, right? We have our kill criteria, right? This is a concrete section we asked for from this template. This looks great. We have Ethereum liquid staking opportunity, 6-month time frame, so on and so forth, right? And then we can drop all the way down to Haiku. You can see here, Haiku way off. This problem is too complicated for Haiku, right? And this pattern repeats across the rest of our analysis, right? So this is one more idea that you can add to your toolbox when you're agentic coding. Use the right model for the job. Isolate your system prompts so that you can run them against any model that you want. And make sure you are diversifying. I love Claude Code just as much as the next engineer. We were one of the first channels to cover it. But drop a like and a comment if you were here before and during the early days of covering Claude Code. It's not over. It's definitely not over. Claude Code is an incredible tool. The team is shipping back to back to back, but we have to think as independent actors. We can't overinvest into one tool. Okay, this is a really balanced take out of Anthropic. These weekly limits had to get set into place because yes, people are abusing this incredible tool with 24/7 hour in the background agents and agentic workflows. But it's important that we diversify, right? Every single day we have more and more options emerging. Quinn 3 coder, Gemini CLI with the new Gemini models. Pretty crazy, Anthropic getting kind of defensive here around the API. We'll see how that progresses. Agentic coding tools will continue to evolve as well as the models, but what remains the same is, of course, the principles of AI coding. Keep your eyes on the big three: context, model, and prompt. Understand how to use these three elements to solve problems that you face, because if you master these, you will master Gen AI, no matter the current drama, no matter the current rate limits, no matter the models. All right, stick to the principles of AI coding. I'll be starting the countdown for the phase 2 agentic coding course very, very soon. I'll be locking in a release date for that, so stay tuned for that. If you made it to the end, drop a comment and let me know what you think about the current agentic coding ecosystem and these brand new rate limits around Claude Code. If you're experimenting with alternatives, let me know what you're working with, and I'll use that as a great starting place. No matter what, stay focused and keep building.